All right, kids, we're going to do a couple more of these questions and then have you work on some of these on your own. All right, we're going to check out number 4. All right, number 4 is a cone. All right, and if you check this out, this volume of a cone is 1/3 pi r squared h. All right. The problem on this question is they gave us the slant height. All right, so what we're going to need to do is Pythagorean's theorem to find the height of this cone. All right, and basically 6.5 is your hypotenuse. So we're going to have to go a squared plus 2.5 to the second equals 6.5 to the second. All right, we're going to plug this in. All right, we got 2.5 to the second, and we got 6.5 to the second. All right, we'll just plug them all in. All right, so you're going to have a to the second plus 6.25 equals 42.25. All right, we're going to need to subtract that 6.25 on both sides. And we're going to get a squared equals, 36. All right, so it looks like this one is going to work out nicely, right? If I subtract the 625, we're going to do the square root, and we're going to get 6. So our height's 6. Once we get here now, this should be pretty easy, right? Our volume is pi r squared h divided by 3. All right, our radius is 2.5, so pi times 2.5 to the second times our height, which is over 3. All right, it should work out pretty nice because 6 is a multiple of 3. But because of that 2.5, we're still going to get a little bit of a decimal here. All right, so we got 2.5 to the second times 6 divided by 3. So we're going to end up with 12.5. Remember, pi, though. It says how many cubic inches are in the volume of the cone. So the way they word it, they want you to round to the nearest cubic inch. So we're going to round to the nearest 1. And that's going to come out to 38.269 or 39.269, and rounded to the nearest cubic centimeter. That's going to be 39 centimeters. It is, right? Centimeters cubed. All right. All right, there's one more question I want to show you, all right? This is where they start getting a little tricky, all right? We're going to get into like these application questions more next week, but I wanted to give you a couple, kind of give you a feel for where these questions could go. All right, so if you look at question 8, it says tennis balls are solid in cylindrical cans. I'm sorry, tennis balls are sold in cylindrical cans with balls stacked one on top of the other. All right, tennis ball has a diameter of 6.7 centimeters. To the nearest centimeter, what is the minimum volume of the can that holds a stack of 4 tennis balls? So if you imagine, I would draw a little picture. All right, you got these tennis balls here. There's 4 of them. They're stacked like this. It says they're in a cylindrical can. So if you drew a cylinder around the can, it would look something like this. All right, now it may seem like they're not giving you all the information, but they gave you the diameter, which is 6.7, which means your radius is going to be half of that. All right, which can be 3.35, right? And again, it may seem like they didn't give you enough information, but keep in mind there is 4 tennis balls here stacked on top of each other, and each one of those diameters is 6.7. So the height of my can is going to be 4 times 6.7. There's 4 balls. Each of their diameters is 6.7. So those diameters just stack one on top of the other. All right, so if you multiply that out, you're going to get 26.8. This is your height. All right, so we're going to do our volume. Now it should be easy. We got a cylinder. Pi r squared h. So it's going to be pi times your radius. 3.35 to the second times our height, which is 26.8. All right, if you look at the answers, they want a rounded answer. All right, so we're just going to plug this whole thing in. Let me clear it out. Second pi times 3.35 to the second times it was 26.8. And it's going to come out to 944.87, which is going to round to 945. All right, so give the rest of these questions a try. I'm going to post up solutions. I hope you guys are doing well. All right, email me with any questions. Talk to you guys soon. Bye-bye.